Okay. So good morning, everybody. And for some people, is probably good afternoon, and some people it's um, good early morning. Okay. So I'll give you an opportunity, each person, to introduce yourself, and then I'll show you some of how we will start. Can everybody hear me well?
Okay.
Yeah.
So good morning, everybody.
Yeah.
And for some people, it's probably good afternoon.
Oh,
For some
sorry.
people, it's
I have to do this. Okay. So who would like to introduce himself first? I will tell you. So just in 1 minute, you tell us whether you're in high energy condensed matter or geophysics, and where you are joining us from. Okay. So the first person is Adons. So Adons, please go ahead. No, you have to unmute yourself.
Hello, good morning. Morning.
Good morning.
I'm augmenting to Adams.
Okay.
Geophysics student from Makerere University.
Okay. Thank you. So the next person is Andijo Olatubosun. So unmute yourself and tell us about yourself.
Hello, good morning.
Good morning.
So
yeah, tell us, are you in high energy condensed matter or geophysics, and where you are joining us from?
I'm in the condensed matter physics group, and yes, I'm calling from Lagos, Nigeria.
Okay, thank you very much, Andijo. Josefa Brema.
Hello, Mr. Mololo. Hello, everybody.
Yeah.
Okay.
So tell us whether you are high energy condensed matter or geophysics, and where you are calling from.
Yeah, I call you from Sudan. My interest is the high energy physics.
Okay, thank you very much.
Thank you.
Okay. Buhafs Fares Sami. Sami. Yeah.
Hi. Do you hear me?
Yes, we hear you.
Good morning, everybody.
Good morning. Yeah.
My name is Faris Bahafs. I'm from Algeria.
Okay.
And I've applied for high energy physics.
Okay.
I'm interested in.
Okay. Yeah. Thank you very much, Sami. Lamini Mangaliso.
So, hi everybody.
Yeah, good morning.
Yeah, good morning. Can you hear me?
Yes, absolutely.
So my name is Lamini Mangaliso Lise from Swaziland. So I've applied for geophysics.
Okay, thank you very much. Abdallah Ahmed. So unmute yourself and tell us which area and where you are joining us from. Abdallah. Okay. So we go now to the next
Hello?
person.
Hello?
Yeah. Yes.
Hello,
Abdallah.
hello. I am with you.
Okay,
yeah,
good.
I am Abdullah from Sudan. I applied for condensed matter physics.
Condensed matter, okay.
Yeah.
Thank you very much. Yeah.
Yeah.
Yeah. Benis.
Hello.
Yeah, Benis.
Hello.
Yeah, hello.
Hello.
Yeah, hello, Benis.
Yeah, I'm Denise. I applied for condensed matter physics.
Okay. Where are you calling? Where are you joining us from? Okay. The next is Elise. Sorry.
Oui. Hello.
Yeah, Elise.
I'm Elise.
Elise. Okay.
I'm applied in conducted matter physics.
Okay. Where are you joining us from?
I live in Kigali.
Okay. Thank you. The next person is Gustavo. Gus.
Hello, my name is Gustavo. I am from Peru and I applied to high energy physics.
Okay, thank you, Gus. Yeah.
Thank you.
So Jean-Paul.
Hello.
Yeah, hello.
My name is Jean-Paul Hagumimam from Rwanda. I applied for condensed matter physics. Thank you.
Thank you, Jean-Paul. Yeah. Kaziba Stephen.
Yes, good morning, everyone. My name is Kaziba Stephen. I applied for condensed matter physics from Uganda.
Okay. Thank you very much, Kaziba. Stephen. Yeah. The next person should be Jean Bosco. Jean Bosco, yeah. Jean Bosco. We can't hear you yet. Hello, Jean Bosco. Okay. Yeah. Go ahead. Yeah.
If this statement is false, then
yeah, we can hear you now.
Maybe I will investigate this more and then try.
Okay. Okay. Who is Kaluchira or Kalusira? So Kalusira. Kalusira. Okay. Okay. Let's go on to the next person. Let's see. Manzi Chest.
Hello.
Yeah.
My name is Muhuza Manzi and I'm in Kigali. I applied for high.
Okay, thank you very much. Yeah. Then Miran.
Hi everyone. I'm Mehran Jalali from Iran. My field is high energy.
Okay, thank you very much, Miran. Quadri.
Yeah. Good morning.
Good morning.
Yeah, good morning. This is Quadri from Nigeria. I applied for condensed matter.
Okay, thank you very much, Quadri. Rafael Martinez Rivero. Who's Rafael? So Rafael.
Hi.
Hi.
It's Jessica. I'm connected for
Jessica.
that is not me. I'm Jessica from Venezuela and I applied for high energy physics.
Okay, thank you very much, Jessica. Remy.
Hi everyone.
Hi Remy.
You hear me?
Yes, we hear you.
Okay, my name is Lemit Krinjiman. I'm joining from Rwanda. I applied for geophysics.
Okay, thank you very much. Yeah, Remy. Console.
Oh, thank you. I'm Console Malagishimana. I'm in Kigali. I applied in condensed matter physics.
Okay, thank you very much. So let me ask you a question. Has everybody received the? Sorry, let me put it this way. Who did not receive the schedule, the calendar? Who did not receive the schedule? So if you did not receive the schedule, you can just indicate in the chat. So I hope everybody can see that there's a chat, and with the chat, if you want to say something, you can just use the chat and be able to tell us everything. The other thing is you should be able to also, if you have a comment or you want to ask a question, you can unmute yourself and ask the question. Okay. Try to make sure that your background is as quiet as possible so that it does not interfere with us. So who did not receive the academic calendar? Okay. So I just typed the question now and I asked who did not receive the academic calendar. Okay. Yeah, Fares, Sami, did you receive it?
Yes, yes, sir.
Okay. Okay. Did you have a question?
Actually, no, I think I mailed my questions and I think I'm quiet.
Okay, thank you. Yeah.
Okay.
So I'll be teaching the math method course. There's a lady, a professor from Arizona, who will be teaching Python. So she'll be helping us in scientific Python, because for many of the courses, or actually for some of the courses, you need to know some scientific Python. How many of you have done Python before? You know about Python. So if I say Python, you know I'm not talking about a snake or something.
Yeah. I did it myself.
Okay. So if you've not, she will try to explain to you and teach you how to use Python. The other thing she will try to explain to you is also teach you how to use Unix or Linux. In scientific work, most of us use Linux or Unix. We don't use Windows, many of us. Okay?
Yeah.
In scientific work, we mainly use Linux or Unix. So she'll be teaching you about how to use Linux or Unix. And also she'll be teaching you about how to plot different graphs, because it's important to know how to plot, make scientific plots. She will teach you some things also about machine learning. Sorry, not machine learning. She'll teach you some things about linear algebra and about differential equations. Okay, so she's going to start next week. It's going to be at 3 p.m. Rwandan time. Okay, so 3 p.m. Rwandan time, that's GMT +2. Okay. Okay. Thank you very much. Yeah. So I'll start you off with this one. So we'll, in like 15 minutes, we'll end this one and then we'll meet again in the afternoon. The reason we meet in the morning and in the afternoon is we'll just check how your connections are, so that when we have classes in the morning or in the afternoon, you know how great things are. At the same time, we are recording this, so I'll send you the recording. And at the same time, we are broadcasting it on YouTube. So if you go to YouTube, you should have something being broadcasted. Let me put it in the chat so that I'll show you how to reach it. So if you follow ICTP. So if you try this, I think it should take you to our YouTube page. Or maybe it's this. I think it's the first one, IFR-ICTP. So you can go there and see that you are being shown live. Okay. So Can everybody see my screen?
Yes.
Okay.
Yes, I see.
Yes.
That's good. So I have these questions. I'm going to send this to you. There are many questions on this page, and there are questions that are useful for you. Some of them are simple questions that you could have done in your first year. Some of them are not. Okay, but it's good to revise and to see maybe where you are lacking, and then we can try to fix it later on. Okay. One of the things we are going to talk about the Dirac delta. Okay. So if you don't know what this is, we'll illustrate it later in the course. Okay. So I'm going to send this to you, or a variant of this, a version of this, so that you get your feet wet. Okay. So let's start with this one that I've written here. Number one. So we'll just do this number one, and then we'll discuss about it, and then we'll end for this morning, and then we'll meet again in the afternoon at 2 p.m. Kigali time. If I'm speaking too fast, please slow me down. So A cross B, okay, and then cross C. So A cross B in bracket cross C. Is this the same thing as A cross in bracket B cross C? What do you think?
Not equal.
What?
It's the same thing, sir.
Why do you think it's the same thing?
I think
because it's
products are associated.
This is the same thing. So can you see what I'm writing now?
Yeah.
Are they the same thing?
No, not equal.
How many people think they are
equal?
What?
They are not equal because the cross product
is the axis.
So how many people think they are equal?
They are not.
Is it? They are equal.
So they are not equal. Okay.
They are equal.
So they are not equal.
Yes.
They are not equal. Yeah.
They are not.
What? How can we show whether they are equal or not?
The axis.
Okay. Unfortunately, I have to meet everybody. And then. Okay. So if you want to speak, you unmute yourself. You speak, and then you mute yourself back. So how can we show whether they're equal or not? Actually, in this case, I'll tell you beforehand, they are not equal. Okay. How can we show this? Okay.
So
who wants to? Yeah, Sammy. Yeah.
A cross B is perpendicular. The plane where A cross B is perpendicular to C, and in the second equality.
No, the plane of A cross B is perpendicular to A and B.
I didn't hear you. Come again.
Okay. A cross B is perpendicular to the plane defined by A and B. It's not perpendicular to C.
Yeah, and the C is perpendicular to the two axes. So
no, C is not perpendicular to the two axes. A cross B is perpendicular to the plane defined by A and B. Okay, right? So if this is A and this is B, A cross B is this.
Yeah.
So this is A cross B. Okay. So C can be anywhere. C can be here. So C can be anywhere. C can be here. It doesn't have to be in the plane of A and B. Okay. So C can be here. Okay, they're not equal. AB sine theta cross A. Yeah, but AB sine theta is not a vector, it's a scalar. Okay. So actually they're not equal, but how would you show it?
Okay. We can explain that by A times B sine theta across product C So that means equal to AB sines theta, C sine theta. So the left hand side must equal to A times B times sine theta across all across.
Okay, there is a problem. Okay, well, there's a
C.
problem.
Yeah. I am trying. I am trying to that. Yeah. Okay. Yeah.
Okay, there's a problem with the argument you just made. A cross B.
Yeah. Okay.
Is going to give you AB sine theta.
Sine theta. Yeah. Okay.
Wait, no. And then a unit vector that is perpendicular to A and B. Because it has to be a vector.
Yeah.
Okay.
I miss the unit vector. Yeah. N.
Okay.
Yeah.
And then if you cross it with C, if you cross it with C, we see. So everything will give you AB sine theta.
Yeah.
And then now have C.
Yeah. Now here. I stuck here. Yeah.
Sine phi.
Yeah.
Okay. Times a unit
Sine
vector.
phi.
Let's call it
Phi. Yeah.
U hat
Phi.
is a unit vector
exactly.
perpendicular to N at C.
So we have a new vector. Is U here?
Yeah. And then if you do the one on the right, you can see that you won't get the same thing. Okay.
Yeah, exactly.
Actually, there's a simpler way to show this. One of the things you'll find is sometimes it's easier to prove things by contradiction than to try to prove it directly.
Yeah.
Okay.
Yeah, exactly.
So I'll show you a simpler way to do this. Okay. So let's assume that A.
Yeah.
Okay. So
I am writing with you.
Let's assume that A is what you call I or X hat. So it's a unit vector along I, along X.
Yeah.
Let's assume that B also is the same thing, a unit vector.
Yeah. Is J? Is JY?
No. Sorry. Both of them we assume that unit vectors along the X direction.
All of them. Okay.
No, both of them. And then C, let's assume that C is J. Which is unit vector along the Y direction.
Okay.
Everybody see this?
Yeah, I see it clear.
Okay.
Yeah. So the vector A and B are the same direction because the unit vector is N associated with it.
Yeah, but okay. So now with this let's calculate A cross B. What's the answer for A cross B?
A cross B.
Yeah.
Okay. Is equal to X hat is I hat times X hat must be.
Okay.
Is a square.
So, yeah, but someone should tell us what do we get if you do A cross B with this.
It's
C cross A.
Yeah. So what's A cross B?
It's 0.
Exactly 0.
0, yeah.
So A cross B is 0 because of the sign, right? It will be 1 times sine of the angle, which is 0. Okay. So with this, we get that A cross B.
Yeah.
Equals I cross
because
I.
it's sine. Yeah.
Which is 0.
Exactly.
Okay. So A cross B cross C will be 0.
It's equal 0. Yeah.
Cross J.
C is equal 0. Yeah.
0. Okay.
Yeah.
So let's now first do B cross C.
Okay. B cross
Remember,
C.
B is I.
Yeah.
C is J. Okay. So what's B cross
It's
C?
K.
Is 1. Is J.
Is K.
Yeah.
Third axis.
Or is V hat, right?
Yeah.
Then if you do A cross B cross C, so that will give you I, right? Cross cross K.
J.
What is
J,
I cross K?
J. It's
J.
mine's.
Are you sure?
Mine's J. It's minus J.
Exactly, it's minus J.
Yeah.
Okay. So you see, you don't get the same result.
Is J.
It's K and this one is minus, yeah.
Minus J. So you don't get the same result. So you
Zero
get
and
zero, and it's not equal to minus J.
This is what I do mean by when I talked about the perpendicular axis. The first.
Oh, no, they don't have to be perpendicular. So this is one of the things. Okay. So I gave an example to show that A cross B cross C is not the same thing as A cross B cross C.
No, I mean the first insights, not.
Yeah, I understand. I gave an example to show that they are not the same. Okay. An example is not proof, but the counter example is proof or counter proof. Yeah. So the fact that you give an example does not mean, for instance, I can give another example where A cross B cross C is the same thing as A cross B cross C. Okay. So just giving an example does not show that it's correct. But giving a counter example does show that it is not correct. I hope everybody understands this.
Yeah, well, it's very well.
So I'll mute everybody's mic. If you're not speaking, just mute your mic.
Okay.
And you can unmute yourself. Okay. So what I've said is, okay. This is fine. So what I've said is, you can give a counter example, which we have just done, and it shows you that A cross B into bracket cross C is not the same thing as A cross B cross bracket open B cross C bracket close. Okay, so you can give an example to show this. Okay, sorry, a counter example to show that this does not hold. Okay, there's another way you can do it, is you can write your matrix A. You can write it as AX. So let's write it in the components. And you can write something similar for B and something similar for C. Okay? And then you can take the cross products. You get some long thing, and then you show that they're not the same. Okay. So you can calculate A cross B. Okay. I'm going to write something now, and what I will write is we physicists understand it, but mathematically it doesn't make any sense. Okay. So usually we physicists will write A cross B. We do something like this: I, J, K. Okay. And then we do AX, AY, AZ, and then BX, BY, BZ. And then we try to find determinants, like use the approach of finding determinant. Don't show this to a mathematician because this does not make sense. A is a constant, a real number or complex number, and B also, BX. But I is a vector, J is a vector, K is a vector. So for a mathematician, this kind of object does not make sense. But we know what we mean when we do it in physics, okay? So in physics, we mean that this is AY, BZ, minus BZ, AY. Okay, and then minus J, AX, BZ, minus minus BX, AZ, and then plus K. Okay. So this is what we mean when we do it as physicists. Okay. But to a mathematician, this makes absolutely no sense because I, J, and K are vectors. They're not C number or complex numbers. Okay. So you can do this, and then after that, you can do A cross B, okay, cross C. You can repeat everything, and you see that you do similar thing for A, for B cross C, and you cross this, and you see that they are not the same. Okay, so you see that it's not the same thing as A cross B, cross C. Okay. There's yet another way to do it. Okay, so Gus in the chat, if you look at the chat, is telling us a way to do it. I'll briefly describe this way, but then there are different variants of it, and you can meet other people that can tell you more about it. And that is to use, I'll write A cross B. Okay. The ith component of A cross B, we can write it using
epsilon.
Levitivita symbol, epsilon I JK. So, sorry, we'll tell you more about this later. Okay. In this thing that I've written, there's a sum that is here, but we don't write the sum. So I'm summing over J and K. But we don't write the sum. We just say that if you repeat the indices, then you are summing. Okay. We'll do all this later on. So repeated indices implies summation. So you can use this also to show that they are not the same. Okay. So if you write A cross B cross C, okay, you will end just now. It's important to tell exactly where the brackets are. Just writing A cross B cross C like this, like I've written here, does not make sense. You get different results depending on whether you do A cross B first or you do B cross C first. So you get different results. So in this case, it is very important that you put the brackets. Okay. So this A cross B cross C is not defined. Okay. What if I do this? Okay. So this A dot B cross C, do I need to put the brackets to tell you which one to do first?
No.
Okay. So
The
if you said
brackets are not necessary.
Okay, why do you say the brackets are not necessary?
Because it shows us that this is a dot product where we are dotting A dot vector B and C.
Okay, so why is the product bracket not necessary?
The scalar product.
So in this case, there's only one way you can do this thing, right? Because you are finding the dot product.
First.
Yeah, so you cannot first find the dot product and then find the cross product. If you find the dot product, you get a scalar. Then how would you cross it with a vector? So you cannot do that. Okay. So what you have to do first is you have to do B cross C first. Okay. So you have to do B cross C first, and then you dot your result with A. So there's only one way to do this. So B cross C. Okay. So there's no other way to do this. Okay. So you don't have to put a bracket in this second case. In this first case, you need a bracket. Okay. To tell us which one we should do first. In the second case, you don't need a bracket. I think one more thing I'll just write. Absolutely. So the cross product will be done first. Thanks. And then I think one more thing I'll just say about this is in the afternoon, you tell me whether this is the same thing as C dot B cross A. Okay. So is this the same thing as C dot B cross A? Okay. And okay, so you tell whether it's the same thing as C dot B cross A. Sorry. So you tell whether it's the same thing as C dot B cross A, and you tell whether it's the same thing as C dot A cross B. Okay. Okay, so I think we'll stop here, and then we took more time than I thought, and then we'll meet again at 2 p.m. to try things out just like this. If you have any comments about what we have done, both the content and the delivery, meaning like Were you able to hear clearly and things like that? Just send us an email at admissions@ifr.org, and then we'll be able to see if we need to adjust anything and things like that. Okay. So thank you very much.
I have a question, bro.
Yeah, quickly. Yeah, go ahead.
Yeah, can you send for us what you mentioned there?
Yes, I will.
Please,
email
can you
this
send for us what you mentioned? Yeah, okay.
Yeah, I will email this to you. And also, I sent you a link. And in the link, you should be able to see that you are online on YouTube. And at the same time, also, we have a recording, and we can send you the recording also if anybody needs the recording. Okay. So we meet in the afternoon at 2 p.m. Oh,
Hi,
sorry.
Mololo.
Yeah, before we go, you need to meet Dr. Machado. Okay.
Hi, good morning, everyone, or good afternoon for someone.
Yeah, good morning. Yes, from Sudan. I am Abdullah.
So, yeah, I am Marcello Musso, Marcello for short, and I will be teaching classical mechanics to you this year. So we will start next week. Yeah, so I hope it will be good for everyone. I hope that you will be able to follow even in this modality, which is a little strange, but we are trying to do our best. So that's it. I will be with you again also this afternoon. Maybe I will also. Okay, I will this afternoon. I will try my own equipment so that now everyone is free to go because we are running over time. That's it. So I will be happy to see you later today.
Okay. Thank you very much, Marcello. So Dr. Marcello is one of the scientists at our institute. For those of you who will be doing cosmology, so this is the person to talk with. And if you want to meet Professor Steve Weinberg, he can. No, I stopped. Okay. So he knows Nobel laureates, and he was the one that helped us to get a link with Professor Steve Weinberg when we had a seminar. So he will talk with you in the afternoon. He will talk more with you in the afternoon. Thank you very much, Marcello. Yeah, thanks.
Thank you.
Bye.
Goodbye, everyone.
Yep.